This lesson is on polynomial long division. Consider the division problem 1519 divided by 7, which could also be written as a fraction or using the long division bar. Find the result of this division using the standard long division algorithm. Is there a remainder in this division? So again, reviewing how to do long division. So we put 7 on the outside, 1, 5, 1, 9 inside. We start with the first digit. Can it divide? No. So we take the next 2 digits. So it divides in twice. Multiply, draw your line, switch your sign. Subtract them, it gives you 1. Carry down the next one. Does it go in? Once. Multiply, draw your line, switch your signs. So we have 4. Bring down the 9. 7 goes into 49 evenly 7 times. Therefore, we multiply, which is 49, and it equals 0. So, is there a remainder in this division? No. No remainder. So now evaluate 1522 divided by 7 using long division. Write your answer in A plus RB form and in A plus B over C form. So, the first one, do your division. So 7 into 1522. We already know twice here. 14, draw your line, switch your sign. 1, bring down the 2, goes in once. 7, now we have 52. And we should also know that since it's 3 more than this, and 3 isn't divisible by 7, that is our remainder. So we have 7 here, 49, draw your line, switch your signs. So we have 3. So our answer, our A, is 217 plus 3 over 7. Okay? All right. Next. Oh, that was C. Sorry. Rewrite your result from A as an equivalent multiplication. So our answer is 217. We multiply that by 7, and it's going to equal 1519. So rewrite it as multiplication. So we have 217 plus 3/7 times 7, and that is going to equal 1522. Okay, so that's a way you can check. All right. What I really need you to do right now is to pause the video and read your long division using variables, because it's very different but very similar, especially if you really get the process of dividing numbers. So go ahead and read the step-by-step of the next page, so this page and the next page, and then let's do a couple examples, okay? All right, they gave you an example with a remainder, so hopefully you read that. If not, again, pause and read through that. Let's try exercise 2. So divide x to the 4th minus 3x plus 5 by x minus 4. So we're going to use our long division bar. We're going to put x minus 4 outside. We're going to put the polynomial inside. But here's the difference. You have to have all the terms in there. So we are going to put zeros for the missing terms. So plus 0x to the 3rd plus 0x squared minus 3x plus 5. And again, if you remember way back, elementary school, this was, those zeros are placeholders, okay? Sometimes we need those placeholders. So you're going to take the first term in the divisor, and it's going to go into the first term of what's under the division sign. So x goes into x to the 4th, or x to the 4th divided by x gives you x to the 3rd. Now I'm going to take x to the 3rd, multiply it by x, and that gives me x to the 4th. I'm going to take x to the 3rd and multiply by -4 and get -4x to the 3rd. Draw my line, And since I'm going to subtract, I'm going to switch my signs. So those cancel, and I have 4x to the third. Bring down the next term, so 0x squared. Again, it's always this first one. So the first one divides into 4x to the third, and it gives you 4x squared. So hopefully you can do those things in your head. Then we're going to multiply. So 4x squared times x is 4x to the third. 4x squared times negative 4 is negative 16x squared. Draw your line, switch your signs because you're subtracting. Those cancels, so we have 16x squared. Bring down your next term. So the first term into the first term is 16x, so we divide those. Now we multiply, so 16x times 16x times x is 16x squared. 16x times negative 64 is times 4 is negative 64x. Draw your line, switch your signs. Those cancel or give me 0, so now I have 61x. So the first term into 61x is just 61. Multiply now, so 61 times x is 61x. I forgot to bring down my 5. 61 times negative 4 is 244. Sorry, that should have been negative, but as I draw my line and switch my signs, it becomes positive. So now I have 249. This is your remainder. Okay. So how do I write my answer? Well, a lot of times they'll tell you the form. The most common form is to take your answer, and just like we did in our first example, you're going to add your remainder on the end, and it becomes a fraction. It's divisible by what you divided by. So there's your answer. Pretty cool. All right. So if I took x minus 4 and multiplied it by all of this, I should get x to the fourth minus 3x plus 5. So that is a nice check. All right. There's also, if you Google long division or polynomial division or anything like that, there are calculators online that you could also use to check your answer. Okay. All right. So the last one. It's another goofy one, meaning I tried to trick you up. So I'm dividing by 2x plus 1, and what am I dividing it into? Well, this is not in the right order. Okay? It's not in that standard form. So you want to make sure when you divide that it is always in standard form. So my highest exponent is x to the third. So I have 12x to the third. Then I have plus 20x squared. Then I have plus 11x, and then plus 2. All right. So now we're going to do the division. So 12x to the third divided by 2x is 6x squared. So now do your multiplying. So 6x squared times 2x is 12x to the third plus 6x squared. Draw your lines, switch your signs. Those give me 0, so now I have 14x squared. Bring down my 11x. 2x divided into 14x squared is 7x. So now 7x times 2x is 14x squared. 7x times 1 is 7x. Draw your line, switch your signs. So now I have 4x. Bring down your 2. So 4x divided by 2x is 2. So 2 times 2x is 4x. 2 times 1 is 2. Draw your line, switch your signs. 0 is my remainder. So my answer is 6x squared plus 7x plus 2. Here's the really cool thing that we're going to learn in the future. If you get a remainder of 0, then this thing that you divided by is a factor of what it's being divided into. Okay? So this is a factor of this polynomial. X minus 4 in the previous one is not a factor of that polynomial because I had a remainder. Okay? All right, good luck with that. If you have any questions, don't hesitate to ask.